Have you ever looked at a massive, complex building and just wondered, how on earth did they pull that off? How do you get from a simple drawing to a fully operational, intelligent structure? Well, that's exactly what we're going to break down today. We're going to walk through the entire life cycle of a modern engineering project, from that very first blueprint all the way to its living, breathing digital twin. Let's dive in.
So, here's our game plan. We'll start with the project governance. That's the rulebook. Then we'll get into design and how that translates to the actual site work. We'll cover construction and quality control, then testing and commissioning, which is where we bring the building to life. And finally, we'll look at the really cool stuff, how automation and digital twins are completely revolutionizing how we do things. So, what's the one thing that separates a project that runs like clockwork from one that's just a mess of delays? It all starts with the blueprint.
Okay, so before you even think about ordering a single nut or bolt, you need a rock-solid foundation. And in project management, that foundation is all about governance. The gold standard for this, the framework that keeps everything in check, is what's known as the Project Management Professional or PMP approach.
Now, PMP isn't just a list of friendly suggestions. It's the rulebook that prevents total chaos. Seriously. It defines everything, the scope, the schedule, the costs, the quality, right from the get-go. This creates a kind of universal language that everyone, and I mean everyone from the civil engineer to the HVAC tech, can understand. And that clarity, that's what stops you from having to do work over and over again. And it makes sure everybody knows exactly what piece of the puzzle they're responsible for. So what does this look like day to day? Well, it's about real, tangible actions. You start with something called a work breakdown structure, or WBS. Basically, you take the whole massive project and chop it up into small, bite-sized tasks for each team. Then you use a RACI matrix that stands for responsible, accountable, consulted, and informed to make it crystal clear who owns what. And the secret sauce? You track it all with weekly KPIs, or key performance indicators. These numbers don't have an opinion. They just tell you the facts about your progress, and more importantly, where the problems are starting to pop up. All right, with our rules in place, we can get to the heart and soul of any engineering project, the drawings. These are so much more than just lines on a screen. Think of them as living documents that guide every single move that happens on site.
You know, a drawing actually has its own life cycle. It starts out as an issued for construction or IFC drawing. That's the big picture design that the client has signed off on. But where the real magic happens is in the shop drawings. This is where engineers for all the different systems, mechanical, electrical, plumbing, you name it, coordinate every single detail. They make sure a massive air duct isn't scheduled to go in the exact same spot as a structural beam. Getting this right prevents crazy expensive mistakes on site. And then finally, once everything's built, you have the as-built drawing. That's your ultimate record, the absolute truth of what was installed and where.
And of course, none of this is just made up on the fly. Every single design has to follow super strict industry standards. You'll see acronyms like NFPA for fire safety, or ASHRAE for heating and air, or IEEE for electricals. These aren't optional. They represent decades of collected wisdom, and they're what ensures that the things we build are not just functional, but more importantly, safe for everyone.
All right, let's step away from the computer screen and get our boots on the ground. We're heading to the construction site. This is where all those plans meet cold, hard reality. And it's where a relentless focus on quality is the only thing that separates a great project from an absolute disaster.
You know, there's a very clear, logical sequence to construction, and it's all designed to avoid doing things twice. You can't start installing light fixtures before the major conduits and ducts are in the ceiling, right? And you definitely can't close up the walls before you've tested the pipes inside them. Trust me, finding a leak after the paint is dry is a nightmare nobody wants. So following this sequence from the big structural stuff all the way to the final paint job is just absolutely critical.
Now, you'll hear people throw around the terms quality assurance and quality control like they're the same thing, but they're totally different. Here's an easy way to think about it. QA is proactive. It's about setting up the process to prevent mistakes. It's making sure you have the right materials and the right plan before you start. QC, on the other hand, is reactive. It's the hands-on inspection. It's the person on site with a clipboard and a measuring tape finding defects after the work is done. You absolutely need both working together.
And this is where the inspection and test plan, or ITP, comes in. These checkpoints are like non-negotiable quality gates. A hold point means exactly that. All work stops until a QC inspector comes and signs off on it. A witness point means the inspector has to literally be standing there watching the test as it happens. These aren't just bureaucratic steps. They are the hard stops that guarantee quality and prevent some really catastrophic failures down the road. So the building is up, the equipment is in. Now for the really exciting part, testing and commissioning. This is the moment of truth. This is where we start flipping switches and turn a collection of wires, pipes, and ducts into a living, breathing, fully integrated system.
Commissioning isn't a single event. It's a careful 4-stage process built around safety and performance. You start with pre-commissioning, basically checking every wire and connection before you dare apply power. Then comes commissioning, where you power up equipment one by one. After that, you do functional testing, where you simulate real-world events. And then comes the grand finale, the integrated systems test. This is where you prove that if a fire alarm goes off, the HVAC system correctly shuts down the right fans. The results from all this become a super important part of the manual for the people who will actually run the building later on.
So what does this actually look like? Well, for the electrical team, it's making sure circuit breakers trip exactly when they're supposed to. For the HVAC folks, it's getting out their instruments and confirming that every single room is getting the perfect amount of airflow. And for the fire safety crew, it's triggering an alarm on purpose to prove the pumps fire up and deliver the right water pressure. Each one of these tests is a critical piece of the final puzzle. So managing all of this, the governance, the drawings, the inspections, the tests, it's a massive undertaking. For years, it's been a nightmare of spreadsheets, emails, and phone calls. But today, we can build a 24/7 digital project management office that automates all that grunt work and frees up engineers to, actually engineer. Let me paint a picture for you. Imagine a technician on site sees a leaky valve. Instead of making a phone call that might be forgotten, they just snap a photo and send it on WhatsApp. An AI engine immediately analyzes it, figures out it's an urgent plumbing issue in a specific area, and automatically creates a high-priority task for the right engineer. It logs the issue in the database, sends a notification to the project manager, and adds it to the daily report. All of that in seconds. This is how you eliminate human error and create a perfect digital trail of everything that happens. And, the best part is that this kind of tech is way more accessible than you might think. Tools like Make.com or Zapier let you connect all your different apps together without writing a single line of code. For more complex stuff, there are platforms like NN. The bottom line is, you don't need some massive tech budget to start automating your projects and saving a ton of time.
So where is all of this headed? What's the ultimate end game when you combine all this data, design, and automation? Well, it leads us to something truly incredible: the digital twin.
A digital twin is so much more than just a fancy 3D model. It's a living, breathing virtual copy of the physical building, and it's connected to it in real time. It's the ultimate bridge between the digital blueprint and what is physically happening on site right this second.
So why is this such a game changer? Well, you can see construction progress updated live inside the model. You can see real-time energy usage from sensors layered right on top of the design. This makes predictive maintenance possible. Imagine getting an alert that a pump is vibrating a little weirdly, so you can fix it before it fails and floods a room. And for the team that runs the building long-term, it's like Google Maps for their facility. They can instantly find any piece of equipment and pull up its entire history with a click. All that data from the as-builts and tests finally has a permanent, easy-to-use home.
And just like with automation, this isn't science fiction that's decades away. It's becoming surprisingly accessible. There are platforms like Matterport that can create incredible 3D scans of your site, and even free viewers like Navisworks Freedom so your whole team can explore the model. This isn't just for billion-dollar projects anymore. The tools are here for all of us to start building smarter. Which really brings us to the final thought here. With all these tools at our fingertips, for governance, for automation, for creating these virtual replicas, the complete digitalization of engineering